Okay, let's go ahead and get started here with section 7 of chapter 8. This section focuses a lot on the percent equation. And because the next section, we talk about the other way of solving a percent problem, which involves the percent proportion. And kind of, sometimes you might ask somebody, hey, which way is your favorite way to solve a percent problem? You're probably going to get a mixed response from that. Myself, personally, I tend to like the equation more because I just like the algebra, the nature of algebra, kind of the application of it to solving a percent problem. And you might have other people that just say, well, proportions more down my alley. Kind of just obviously it just kind of depends on who you ask. So now if you were to, let's say right now you were to Google, because you can Google anything, obviously, let's say you Google the percent equation, what you're going to probably pull up, you're going to pull up something that looks like this, where it's percent times base equals part. You're going to hear that a lot or see that a lot if you look it up. And the thing about that equation or that the wording of it is the word base. Uh, Sometimes that's not so clear. So base, if you're wondering, base is just another word for whole. Okay, so if you're, the and depends on what the percent problem is. A lot of times the whole is, the original price of a shirt. If you're looking for a discount or something, it might be the price of a shirt without the discount or without tax. The price of the meal, without tax or tip. That could be the whole. The whole um, could be the price of something before, let's say it was made at a factory, uh, and when it's sent out of the factory and sent to a store, with walls and bricks and mortar, um, it's marked up, so it might be the price before the markup. So the whole kind of depends on a lot of things, it just depends on what the problem is, could be anything. So anyhow, like I said, that's your real basic percent equation. Now, keep in mind that equation is great for, I mean, it's great for anything really, but that's great for if you're looking for the parts. If you're looking for what the part is. Now, if we were to kind of apply algebraic inverse operations to this, we can transform this equation into any of the three things that we're looking for. Obviously, this equation right here is great for finding parts. The part, and I don't think I really explained this, but the part sometimes is, it's a lot of things in the percent problem. It could be just the discount, how much is being taken off the price, or it could be the markup, how much is being added to the price, or marked down. Could be, sometimes discount is not called a discount. Sometimes it's called a markdown. It could be the tip. It could be um, how much weight you lost in a week or something. The part could be a lot of things. All right, so another iteration of the percent equation could be, let's say you're just looking for the percent. Let's say if you're just looking for the percent, um, you can do, or I'm just going to write like this: percent equals um, part divided by the base. And times 100 right there. The times 100 part is kind of optional because when you do the part divided by the base, you're going to get a decimal, or, or just, I mean, all numbers are decimals, but you're going to get a decimal. So if you're trying to change it into a percent, it doesn't hurt to remember, hey, I got to multiply by 100, or just move the decimal over 2 places to the right. So that's the second thing that is great for, you're looking for the percent. The problem says what percent, or find the percent. You're looking for the percent. That's the unknown part of the problem. That equation right there will get you what you need. Take the part, and divide it by the whole or the base. Okay. And what's another one? Another one could be the base. Let me just make sure. If you're looking for the base, all you have to do is take the part and divide it by the percent. Okay, divided by the percent. And keep in mind, and I should have probably stated this earlier, keep in mind you got to convert the percent whenever you're dealing with this equation. Oops, I don't know how to spell. Convert the percent into a decimal. You want to do that pretty much in the in the first one and in the second one as well. You want to convert that into a decimal, and when you convert it to a decimal, you're just dividing by 100, or you're just moving over the decimal 2 places to the left, right? To the left. That's all you got to do. All right. So I think sometimes when you're doing these kind of problems, I think sometimes the trickiest part is knowing, what is, because it's not always spelled out for you. It's not always black and white. It doesn't say, hey, this is the base, this is the whole, and hey, this number right here, by the way, in this word problem, this is the part. Usually it's kind of obvious what the percent is. But the base and the whole and the parts problem, the parts are those sections of the problem aren't always crystal clear. So you want to, I guess, when you're setting these things up, you really do want to make sure you're dealing with the right thing. Am I identifying this part of the word problem as the part? Is this the base? Make sure you know what you're dealing with. So I think a lot of times at the end of it, when when you're all through solving the problem, a lot of times you have to end up asking yourself, like, hey, does my answer make sense? Does this make sense? Like, let's say you're looking for a discount on a $50 shirt, and you end up getting an answer like 311 or something. So, and a lot of times you'll be doing things in your calculator, and you'll trust your calculator, like, oh, it gave me 311, but great, your calculator did all the math for you, but does that make sense? Maybe you didn't divide the right thing. Maybe you misidentified the part in the whole. Does it make sense that you're going to have a $50 shirt and have a $311 discount? That doesn't make any sense, right? So you got to think about, hey, these numbers that I'm getting at the very end, does that make sense? I mean, it could be also on the opposite spectrum. It could be like you're dealing with a 30% discount on something on a $50 shirt, and you end up getting like 25 cents. Again, that probably doesn't make sense. That seems too small. Like, you'd think a 30% discount on a $50 shirt, it's going to be a little bit more significant than just a quarter. So always be thinking, I think it's worth reminding people, it's always be thinking about, does my answer, logically, does it make sense? Are we thinking rationally here? Does it make sense? Because a lot of times we kind of just trust, especially when we're using a device like a calculator or something. Does it make sense? It's got to make sense. So that's important. Anyhow, so these first examples here, we've got to translate that into an equation. All right. So and it doesn't say solve, but let's solve these as well. So what is 50% of 80? All right. Now, when you're doing these kind of problems, now it says what is, now that, this seems pretty harmless, but that just means n equals, right? What is n? If it ever says what number or what value, that's an n, that's an x, whatever letter you want to assign it. But I'm going to put n equals, and then 50% is the percent, so I'm going to put 0.5. I mean, if you want to put a 0 there, you can, but you really don't need to. And then times 80. So 80 in this example is the base. Now this is a pretty dry example. This is a very, there's not a lot of stuff going on in this example, but and this is a little bit gimmicky, but that word of, a lot of times, if you're dealing with the word of, that is a good indicator you're dealing with the base or the whole. Okay. Same thing goes with the word is. The word is right there. is a lot of times means the part. Okay, and I know that's a linking verb. Sounds like a language arts class we're kind of talking about here, but that is a lot of times that's going to work out that way. Yeah, so you just do the math here. 50% times 80, or 0.5 times 80 is going to be 40. You probably really didn't even need. I mean, I know what you're probably thinking when doing these kind of problems, but you're like, did I really need to use the equation here? But I mean, it's a good thing to know how to use. So how to use it. All right, anyhow, 70% of what number is 32? Okay, so 70% is our percent. So I'm going to write that as a decimal, 0.7. If you want to put a zero there, you can. You don't really need to. Of what number? Now, of what number? Of, like I said last time, of is a good indicator that you're dealing with the whole, or the base, you know? So times n equals 32. So the is part right there, the is a good indicator we're dealing with the part. All right, so if we write this more algebraically, it might look like this, you know? You got that. All right, and so we're just going to divide both sides, right? We're just going to divide both sides by 0.7, by 7/10. That is what we're going to do. All right, and I get kind of an ugly number there, but so when I hit, no, I'm going to put up approximately. I got 45.714 something something something. So I'm going to say that's about, I don't know, 45.7 approximately. Not exactly, but yeah, that's probably good enough. All right, on this one right here, what percent of 30, what percent of 30 is 24? And I haven't been using this enough. I haven't used it at all, but why don't we use this right here? Let's use this equation, which is the percent equation, right? Part divided by base equals a percent. So part divided by base. So the part is the 24. That's our part. Our base is usually indicated by the of. That's our whole, or our base right there. So part divided by base. So we're going to do 24 divided by 30, and then we're going to multiply that by 100, because we're going to get a decimal when we do 24 divided by 30. So you're going to do 24 divided by 30, all right, and then multiply that by 100, and you get 80. So that's 80%. All right, next one right here, finding the part. All right, so finding the part, I mean, these are all kind of the same thing here. So finding the part is percent times base. That's all you have to do. So percent times base. So we're going to do 10%, which is 0.1, 1/10, times 80. And that's easy. You know, doing 10% of anything, just move the decimal over 1. And so you get 8. There you go. All right, and then right here, we're going to do, this is going to be 32%, so I'm going to write 3200s, 0.32 times 224. So 0.32 times 224, and I got 71 and 6800, 71.68. All right, finding the base is, that's where you take the part and divide it by the percent. Right here, I'm looking at this equation right there. All right, so you're going to take the part divided by the percent. All right, so on this one, we're going to do 91 and divide that by 0.65. That's what you're going to do, 91 divided by 0.65, and you get 140 for that one. All right, for this one, the part is 30. And we're going to divide that by 50%. Remember, always convert it to a decimal. So we're going to do 30 divided by 0.5, which is 60. And then finding the percent is just take the part and divide it by the base, and then multiply by 100. That's all you got to do. All right, so on A, we're going to do 25 divided by 125, and then multiply that by 100. All right, so 25 divided by 125, that is 0.2, and then 0.2 times 100 is 20. And don't forget to stick the percent sign on there. So 20%. All right, what percent of 80 is 0.8? All right, so we're going to do 0.8 divided by 80, and then multiply that by 100. So 0.8 divided by 80 is 0.01, and then multiply that by 100 to get 1. So that's your answer, 1. All right, for this one right here, we're going to translate this into an equation and then solve. So we've got the Smith family paid 22% of the purchase price of a $231,000 home as a down payment. So they're paying 22% of the purchase price of the down payment. So determine the amount of the down payment. Now, in this example, the down payment is the part, right? I would say the 231,000 price for the home is the whole. That's the base. So we're just going to do basic. We're just going to do basic percent equation here. So we're going to do 22% times $231,000. All right. So I'm going to do 0.22 times 231,000, and you get, I got $50,820. Alrighty. All right, Lisa bought a share of a stock for $48.24. She was paid a dividend of $12.06. Determine what percent of the stock price is the dividend. So in this example right here, I would say the price of the stock, the total price, that sounds like the base. It sounds like the whole. Oops, things bugging out on me. That's the base. All right. I would say that the dividend, the part that you get as an investor, that sounds like the part. Okay. And so we're just going to do this. We're going to do 1206 divided by 4824, and then multiply that by 100, or just move the decimal over 2 places. And that comes out to 25%. All right, which is a pretty big dividend. You usually don't get that big of a dividend if you own stocks. If you own stocks, you know you get like pennies for every stock, barely anything. Sometimes it's more, but rarely it's a lot more.